Hello and welcome to another one of D's ADD videos. Today we're going to be looking at some examples of the double angle identities. Mainly I'm just going to look at the sine and 2 theta or 2 box and cosine 2 box identities. These are the identities. You can use the Pythagorean identities to get these two from the very first one for cosine 2 theta. Here's the tangent 2 theta one or 2 box. Now let's look at this problem here. So you should be able to see that the argument on the right hand side is all 3x's here, and it's a 3x here, but this one's a 6x. So what we want to do is we want to use our identity, and the way we need to look at it is as sine of 6x is really 2 times 3x, and your box now becomes 3x, and you can rewrite that as 2 sine box, which is 3x, cosine box. So when you do that, hopefully it becomes a little more apparent that this problem was not as complicated as it looked. It just needed an extra little step. And then if you group your cosine 3x's together, because you can multiply in any order, you're going to get cosine squared and then 2 sine 3x. Just working with one side is typically what I like to do, and prove that it equals the other side. Cosine times cosine is cosine squared, and that's what we have over here. So we put a check mark and move on to the next one. Let's look at this one here. This one looks a little bit more complex. I do see cosine 2x on the right, and I see x's on the left, so I'm probably going to have to use double angle here. Now what I want to do is I want to first FOIL this out, and I notice it's a difference of 2 squares, so I can square the first one minus the square of the second one, and 1 squared is just itself. And then I look at this and I say to myself, well, this almost looks like the Pythagorean identity. If I factor out a -1, I'm left with 1 minus cosine squared of 2x. And that then can be rewritten as minus sine squared of 2x. All right. So this squared can come out in exponent of the parentheses, and here we can use a double angle identity. Oops, I changed, I don't know. I thought this was in thetas to begin with, but it is in x's, so I'm okay. And don't forget it's squared, and there's a negative sign in front of it. And when we apply the negative and the square everything, we get what's on the right hand side, which is a good thing. And we're done. So that's what we have up here. Okay? So you can see that you can use more than just one identity to prove the identities. It doesn't necessarily always have to be just double angle or just sum and difference. You can use a lot of them in combination. The goal is to get one side to look like the other side. And the best way to get good at these is to do as many of them as you can. If you need extra practice problems, please come see me or email me and I will get you extra problems. All right? Practice, practice, practice. Thank you and have a nice day.